Right. Welcome back. Anyway, good day, everyone. I hope you are doing well. And today, I'm just gonna discuss with you the first paper for the physical science. So it's question two. Let's get into it. So it says here, question two. It says they started a new page. So I followed the instruction. So it says the statement that they gave us that two blocks of masses, 3 kg and 8 kg respectively, are connected by means of a light intensible string as shown in the diagram below. The string moves over a frictionless pulley and the 3 kg block is placed on a plane that is inclined. As you can see over here, it's an inclined plane at an angle of 30 degrees. Here is the 30 degrees to the horizontal. A force of 55 N, which makes an angle of 15 degrees. Here is a force of 55 N. That angle that is 15 degrees with the horizontal is applied to the, that means that it's a force applied, this one is applied to the 8 kg block to move the system of the blocks to the right. So it means they are moving to the right. And then now the 3 kg block experiences a constant frictional force of 5 newtons. And then this one is the 3 kg block that experiences that force. And now the coefficient of kinetic friction between the 8 kg block and the surface is a 0.16. One thing, the coefficient of kinetic friction doesn't have the units. You know why? It's because the friction and the Newton, the normal force, have the same units. So it means that when you make that mu k the subject of the formula, they end up canceling each other. So they can ask that question. Be mindful of that. They can ask it, and then one thing you can just do is just to show them that the newtons they cancel them out, and then you are left with no units. So by the way, we are not there, we are here. So now 2.1, it says that state Newton's first law, Newton's second law of motion in words. So we have to state it as a definition. They ask it a lot, so just make sure that you know that Newton's second law states that an object can will accelerate in the direction of the net force, and the net force is directly proportional to the and the acceleration is directly proportional to the net force and inversely proportional to its mass of an object. So I can just say 2.1. I can just say here the f net is equals to ma. When they say state Newton's second law, this means that f net is equals to ma. It means that an object will accelerate in the direction of the net force, and acceleration is directly proportional. What I can just say now is acceleration is directly proportional to the f net, to the net force, and then acceleration also is inversely proportional to its mass. So that's the definition for me. I just write it like this, but you can take the one that I placed in words that says an object will accelerate in the direction of the net force, and the acceleration is directly proportional to the acceleration is directly proportional to the net force and inversely proportional to its mass of an object. So for 2.2 now, they say draw a labeled free body diagram of all the forces acting on the 8 kg block. So now here is the 8 kg block. Now we can see that it is on the surface, horizontal surface there, as they said in the statement. So it means that it has a what? A normal force, and then it has a kinetic, a coefficient of kinetic friction. It means that it has a what? A frictional force. And then we are told about the applied force, and then as usually we have a what? A gravitational force. So now what we can just do is just that we can make a circle bigger, so that it can accommodate everything. So we have a what here? Fg, that means it's a gravitational force. And then we have a what here? We have a normal force, since it's on the surface, horizontal surface. And now since the applied force here, is not since the applied force has an angle, uh, it has an angle, it makes an angle of 15 degrees. It means that we can use the components of the applied force, and then the components of the applied force are Fy, and then we have an F of Fx here. So since we have a coefficient of kinetic friction between the 8 kg block and the surface, it means that we have a what? Since it's moving to the right, it means that our kinetic friction should move to the rest to the left, because it opposes the motion. So we have a what here? A kinetic friction. And then now we have this string that connected over a frictionless pulley. It means that we have a tension there. So we have a tension over here. Tension. So now what I can just tell you to look at when you are answering this question, just look at the marks over there. The marks are at the maximum of 5. And then now what you can just do is just that you can take the all those labeled arrows and say one here, one mark here, and then you combine this one, because it's a component of the what? Of the applied force. And then you combine them, you say the 2, and then you take a Fn, at the normal force you say 3, and then a tension you say 4, and then a friction you say 5. It means that you have all your labels, you have labeled all your free body diagram, and then now the maximum of 5 marks, you should get them. And then now let's look at F2.3. So 2.3 over here, it says calculate the kinetic frictional force that the 8 kg block experiences. So 2.3.1, kinetic frictional force that the 8 kg block experiences. So the kinetic frictional force, since we are told that there we have a mu k, is a coefficient of kinetic friction, that is 0.16, and then a frictional force is made by Fk is equals to mu k times n. This means that it's a normal force. And then now what you can just do, since we have a mu k, let's find out the value of a normal force. And then the normal force there, looking at this labeled free body diagram, the normal force is it's an Fn plus Fy, which is equals to an Fg. That is Fn plus an Fy, which is equals to an Fg. The Fg, which is equals to mg. And then now what we can just do, since we want to find the normal force, we can just say now Fn plus Fy, and then now we can just say Fn is equals to mg and minus an Fy. And then now let's substitute everything that we have this one is an 8 kg block, 8 kg block here, and then we can say an 8, and then a G is a constant gravitational force, constant gravitational acceleration, I mean. So it's a 9.8, and then minus F, an F, that is a what? Because an Fy is equals to an F of a sine theta. So now what you can just do now is just that you can substitute a 55 here, and then we say a sine, and then the angle is a 15 degrees over there. Yeah, it's in 15 degrees, and then that angle is the F is 55 degrees. So I mean 55 newtons. And then now what we can just do is just that we can punch out our calculator and find that value. So it's 8 into 9.8, then minus into 55 sine, that is 15 degrees, and then got a what? A 64.16 newtons. And then now what we can just do is just that we can go back to that equation, that is Fk is equal to mu k of n. So we can just say Fk is equals to a mu k there, it's a 0.16, and then an n, it's a 64.16. And then now let's find out the value for Fk. So it's a 0.16, and then it's a 64.16. And then our frictional force is a 10.227 newtons. So that's it for for 2.3.1, and then for 2.3.2, let's dive deeper straight to 2.3.2. So it means, it says here, calculate the tension and the strength connecting the two blocks. And then now since we have that, what we can just do now is just that we can try to draw the free body diagram for the both the blocks. Now we can just say free body diagram over here. We said it was Fn, Fy, Fy, so Fn, and then a tension over here, and then a friction over here, and then a Fg, and then a Fx over here, Fx. And then now for the 3 kg block, we have also Fn, because it's on the surface of the inclined, so it has a friction, a normal force, Fn there, it's present. And then we have a friction, because we're told about it experiences a constant frictional force of 5 newtons. So it has that friction, that is Fk over here. We can represent Fg with its components, that is Fg perpendicular, and then we have Fg, Fg parallel, and then we have a tension over here, a tension over here. And then now I think we are done with the 3 kg block, the free body diagram for the 3 kg block, and then for the 8 kg block. So now what you can just do is just that for us to get this tension correctly, we can just say, if we can take a look over here, we have a tension that goes this side, you have a tension that goes that side. It means that this one will be our F net, and also in this 8 kg block, this one will be our F net over there. So now what we can just do is for us to take a direction whereby our forces will be positive. And then now let's look at this one, and then let's take uh, let's take a side whereby it will give us the uh, positive uh, positive forces. So it means that if I choose this side for it to be positive, it means all the forces that are going this side, they will be positive. All the forces that are going to the left, they will be positive. So what I can just do now is just that I can say to you, F net is equals to MA for the 3 kg block, and then F net is equals to MA for the what? For the 8 kg block. What can I do now? It's just that I can find the acceleration for the system. So now what I have here is an 8 multiplied by an A. That is an acceleration. And then what is F net for this 8 kg block? It's a positive, a T, that is a tension, with a positive Fk, but with a negative f of x, fx, I mean. And then now that's it for the 8 kg block. And then let's try to find the F net for the 3 kg block. And we say here it's a 3a because we have a 3. The M stands for the mass, and then the A stands for the for the acceleration. So now in order for us to get the F net for this one, let's look at the direction of our positive side, the chosen side. So FG here parallel should be positive with a positive Fk because they are going in the direction that is positive, and then our tension there should be negative. And then that's it for the 3 kg block. Now let's try to plug in everything that we have. So for us to get the Fg parallel, we can just say Mg cos theta. Mg cos theta is the same as Fg parallel. And then for the kinetic energy, for the kinetic friction, kinetic friction on the 3 kg block, it was said to be 5 Newton. So it's a plus 5 and then minus a tension, and then it is equal to a 3a over here. So now let's try to replace everything that we have here. It's a 3 and then 9.8 and then a cos that is cos 30 degrees. 30 degrees plus a 5 minus a tension and then a 3a. And then that's it for the 3 kg block. And then let's try to do the same thing over this side. We don't have a tension. This is what we want. And then for the frictional force that we've got in the previous question, it was 10.27 newtons, and then minus for a f of fx, we can say f cos theta, which is equals to an 8a, and then we say over here now t plus 10.27 and minus, let's try to find f there, it is 55, and then it's cos 15 degrees, and then this is equals to an 8a. And then now what we can just do over here, let's try to add the equations, that is equation 1 and then equation 2 over here. Let's add these both equations. So our second step here, add equation 1 equation 1 and equation 2. Equation 2. So we say now it is an 8a, I'm sorry for that, 8a plus a 3a, which is equals to a 3 into 9.8 times a cos, that is a 30 degrees, plus a 5 minus a t, plus, now let's try to add those plus a t on the bottom side. We say plus a t plus a 10.27 and minus a 55, and then a cos 15 degrees. And then now what you can just observe here is just that this t is has an additive inverse with this one, so we can cancel them out. Even though we want to find them, we can cancel them out, and then what we are left with now is an a that is an acceleration of the system, and we can find that acceleration. And then what we have on this other side is an 11a, and then on this side, let's try to punch our calculator and then see what we've got. So it's a 3 into a 9.8, a cos 30 degrees, and then a plus 5, and then a plus 10.27, and then a minus 55 times a cos 15 degrees. And then what we've got here is just that it's a 11a, which is equals to negative 12.39. So let's try to find this acceleration, and then we say what an answer over 11, and then we get a what, negative 1.13 meters per second square. But what I want you to observe over here is just that the system goes in the right, and then we took a side that is to the left as positive. So it means that that's why we have an acceleration that is negative, because the system is going to the right, whereas we took a left side whereby the system isn't going to as a positive. So if we took the right side as a positive, we should have gotten the positive 1.3 meters per second square. So there's nothing wrong here. So we can just say, therefore, acceleration is the what? 1.3 meters per second square. That's it for the acceleration. And that now what you can just do is for us to take one of the equation that we had, and then we find the tension over there. So now let's pick up one of the equation. Let's just pick up equation 1 and say FG parallel, and then we say plus FK, and then we say a negative t is equals to a 3 into 1.13. 1.13. No, it's a negative 1.13 because we took a left as a positive. So now what we can just say is a FG parallel, or what we can just do is for us to punch the calculator and find the value of FG parallel, and say 9.8 cos 30 degrees, and then we find that value as a 25.46. And then for a FK, our FK will be now for the 3 kg block, it was 5 newtons, and then negative T, and then was equals to that 3 into negative 1.213. And then now 25.46 negative T is equals to, so 25.46 plus a 5, it gives us a what? A 30. That is a negative 30 over here. Negative 30.46. And then now I left this one here. And then we have a negative 30.46 plus 3 into negative 1.3. 1.3, and then what we got, it's so now we add that 3 into negative 1.13, and then what we've got now for a T, the tension will be a negative 33.85 over that negative 1 that was there. So it was negative, and then we said negative so that it can cancel out, and then we have a T that is 33.85 newtons. 85 newtons. So now I hope this one gave you a bit of an understanding of the newtons. So if you do find it helpful, please guys do make sure that you subscribe, you like the video, and you comment in the comment section. That will help me so that I can reach more people. Anyway, if you find it helpful, you can just share it to your peers. So thanks for watching. Until next time, until we meet in the next video. Thanks for watching.